Okay, in this lesson, we're going to talk about half-life time. Half-life time is the time taken for the nucleus to decay to its half value. What does this mean? This means that if I have 100-gram mass, how much time needed for the nucleus to decay to its half mass, which means to reach 50 gram. Total period means the total time needed for the nucleus to be stable. The number of half-lives, we'll understand it more in the problems. Problem number one, if you have a half-life of 4 years, what fraction means what mass will remain after 12 years? 12 years is considered to be here the total period. So direct substitution in the rule, we can get the number of half-lives, which is equal 12 divided by 4 equals 3. Here what he needs, what fraction means, what mass will remain, but he did not give you the original mass. If he didn't give you in the problem the original mass, you will suppose that the original mass is 100 grams. So after 3 half-lives, each time you will decrease the mass to its half value, 100 divided by 2, 50, 50 divided by 2, 25, 25 divided by 2, 12.5. So the remaining mass is 12.5 grams. Problem number 2. Element X is radioactive and decays via alpha decay with a half-life of 4 days. So here I have the half-life 4 days. If 12.5 remains from the sample, so I consider that the remaining mass is 12.5 grams. Okay, this is given. From this, I can suppose that the original mass is 100 grams. So from this, I can know the number of half-lives. 100 divided by 2, 50, 50 divided by 2, 25, till we reach 25 divided by 2, 12.5, till we reach the mass remains, okay, which is 12.5. So we pass by three half-lives. So direct substitution in the rule, half-life period times number of half-lives, which is equal 4 times 3 equal 12 days. The last problem is the same idea, but the only difference here that he gave you the original mass. So you're not going to consider it 100 gram. Okay, and direct substitution also in the rule. He gave you here a patient undergoes treatment for thyroid cancer, receives a dose of radioactive iodine, which has half-life of 8.05 days. The original dose contained 12 milligram. What mass remains after 16.1 days? So I have the total period here 16.1 and I have the half-life 8.085. So I can do 16.01 divided 8.05, which is equal to, and then I will take the original mass 12 milligram and I decrease it to its half value, 12 divided by 2, 6, 6 divided by 2, 3 milligrams. Okay. This is the first part, which is about half-life. The second part we're going to take here what is nuclear force? Nuclear force, I have two forces inside the nucleus. I have attraction force and I have repulsive force. Attraction force happens between the positive proton, and as we mentioned before, that the neutron has positive and negative. So there is a small attraction force between the positive protons and the negative particle found inside the neutron. Also, there is repulsive force found between the protons inside the nucleus. When the atom is stable, we say that the attraction force is greater than the repulsive force. When the atom is unstable, the repulsive force is greater than the attraction force. That's why in the radioactive elements, It's very active, it's very unstable because it has high number of protons. So the repulsive force is greater than the attraction force. Okay, then we're going to take something called transmutation reaction. What is transmutation reaction? Transmutation reaction means conversion of one element into an atom of another element. How can we convert an atom into an atom of another element? In two ways. The first way is radioactive decay. This is what we mentioned before, that you have any radioactive element, it starts to decay by releasing radiation as alpha, beta, positron, and gamma. And during this decay, the atom disintegrates and it changes into a new atom. So this is considered the first way of transmutation reaction. The second way of transmutation reaction is by bombarding the nucleus with a projectile. What does this mean? Bombarding means hitting. That I take a stable nucleus and I hit its nucleus with a projectile. Projectile means small particle like alpha, neutron, proton, beta, okay? And when I hit the nucleus starts to change into a new element, a new substance, okay? This new element, sometimes it's still stable, but I just change it into a new element, or the element formed is unstable like this case, so it starts to release extra particles. So here it releases extra proton and oxygen is formed. So as you see here, as we bombard this nucleus with a projectile, okay, it changes into a new element, and this new element becomes unstable and it disintegrates until it changes into a stable element. Okay, so we have two ways of transmutation. If I asked you in the exam, what are the two ways of transmutation? You're going to say radioactive decay or bombarding the nucleus with a projectile. Okay, the next part is about transuranium elements. What are transuranium elements? Transuranium elements, they are elements with atomic number above 92. All these elements are considered to be radioactive elements. These transuranium elements, what do they do? These transuranium elements, they are all unstable. From 92 to above, they are all radioactive. As you see here, you can take the uranium and you bombard it with a projectile like a neutron, it changes into uranium-92-239. Why do I do this? Yeah, it is unstable and it will decay automatically, but I just bombard it with a projectile and it changes into a new element which is more unstable. This uranium starts to decay, as you see here. Uranium, when it releases beta particle, it changes into neptunium-93, which is above 92. So it is unstable. So neptunium will decay and changes into plutonium 94. So it's still unstable because it has high atomic number. So any element with high atomic number above 92, they are all unstable and they will remain to decay until they change into stable elements. Okay, this is about this lesson, transuranium element. We're going just to have only one lesson remaining in this chapter.